Okay, section 4.2 takes a bit. Again, I'll try to go through it quickly. I'll do two examples at the end. Systems of linear equations in three variables. What happens now, instead of simply eliminating one, solving for the other, and then plugging in, we now have to create two new equations. So what I do on the board when I'm doing these, on the whiteboard, is I like to color code and number. And I'll take what they get. This is example one from the book. I'll just take and say, all right, there's the first one, there's the second one, there's the third one. Then we need to start, and I write it out here, you can pause it, by choosing two, any two. It doesn't matter what ones you choose. I tried to choose the same route the book did so you could follow along. But look at all three and plan your attack. And I made some comments. If we add 1 and 2, there's 1 and there's 2. If we add them together, negative y or plus y minus y, my y's are gone. I eliminate y if I add 1 and 2. Subtracting 3 from 1, if I take this from this, x minus x, my x's are gone. I could eliminate x. Adding 2 times 2 to 3, if I double 2, if I double the second one, I'd have a negative 2y. I add that to 2y, the y's are gone. It all depends on what you see first. Just choose one and, well, I guess the best route is to analyze a little bit and think of a starting point. Or just look for the first thing you see that goes away and choose it. Like this here, you see x and x, like sweet, I can get rid of x. I'm gonna subtract 3 from 1. 3 from 1, the third one from the first one. X minus x, gone. Now I got my y's and my z's. That will give you number 4. Then you have to do that again. So in this case, I took equations 1 and 2, x plus y plus z, blah, 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 and I added them. Adding them made the y go away. Now I have a 3x plus 2z equals 9. I have a fourth equation in 2 variables. The goal now, choose any others that will eliminate y, because I need an x and a z. Now what happens is if you accidentally choose one and eliminate x, you're back to square one. You still have to do another one. The key, find 2 different ways to eliminate the same variable. Here I added 1 and 2 because it was quick and easy. Boom, y's are gone. So 3x plus 2z equals 9 becomes number 4. Now my concern in the future is going to be number 4 and number 5. The fourth and fifth equations I find that I make my own myself, those will eliminate a variable. What I mean by that is over here, since we eliminated y, we got to find a new combination. I said we can multiply equation 2 by 2 and add to number 3. If we multiply equation 2 by 2, we get 4x minus 2y plus 2z equals 6. If we add that to equation 3, x plus 2y minus 3z equals negative 4, my y's go away in this one, and I now have a fifth equation. I made equation 4 and equation 5 on my own. They both have an x and a z. Now I can look at those two and choose a variable to eliminate. So we have a system in 2 variables. I'm showing you this, my notes, because you can pause this video and make sense of them. We have a system in 2 variables. So we can solve for one by multiplying equation 5 by 2 and adding the result to equation 4. So there's my equation 5 I just got. If I double that, I have 10x minus 2z equals 4. If I add that to my equation 4 that I found earlier, my z's go away. I'll solve for x. X equals 1. Now it's a matter of plug x equals 1 into x, one of these places. Either one of these, you plug 1 in either place here, and then you'll solve for z. Once you solve for z, then you'll plug x and z into any of the initial equations. Okay, now one interesting example is example 3. If we start combining, if we say, hey, this is easy enough, I'll multiply the first one by negative 2, add it to the second one, 4x cancels, 6y cancels, 2z cancels, 10s cancels, 0 equals 0. Because it's a true statement, it's dependent, a dependent system. So those are dependent with a system of 3 equations and 3 variables. A dependent system can have no solution or an infinite number of solutions. The book explains that. Then example 4 gave us the other route. Just double check real quick and then know that you're done. If you end up eliminating variables and you get a true statement, then it's dependent. If you eliminate variables and get a false statement, it's inconsistent. There is no answer. There's no solution. 0 equals 26 is downright false. Don't let anybody tell you that's true. So false statement, no solution. Okay, so let's get into some examples for 4.2, some problems from the problem set. I chose number 3. And again, what happens is x, x, y, 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 z, z. You just pick one. Choose one to go with. So I'm going to take equation 1, and I color code it so you don't think I'm multiplying. Equation 1 is x plus y plus z. This is 1, this is 2, this is 3. X plus y plus z equals 6. I'm simply going to add it to equation 2 and get x minus y plus 2z equals 7. When I do, my y's fall out. I have 2x plus 3z equals 30. It's actually clearer on the monitor than it is on my actual paper. That's good for you. 2x plus 3z equals 13. Now, I'm going to stick with number 1 because it's x plus y plus z equals 6. It's straightforward. And I'm going to add it to equation 3 because that has a negative y. Both of them have a negative y. You can use, I just used the same equation. Equation 1, equation 1. I added it to each one individually. Oh, sorry. This is equation 4, where we will use that. We need to eliminate y again. That's why I'm adding equation 1 once again to equation 3, because I see that my y's will go away. I need an x and a z. If you accidentally see, hey, the x's go away if I subtract, then you'll eliminate x's and realize, oh crap, now I got y and z. I can't do anything. So choose one, figure out what you eliminated, and then find another way to eliminate that same variable. Okay, now I completely lost my place. Minus 4z equals minus 9. So doing that, I chose that because my y's will go away. And once again, I have an x and a z. Minus 3z equals minus 3. So now this is number 5. So now what I do is I don't care about the first ones anymore. I'll need those when it comes back to plugging things in, maybe. I can still use what I see here. But I'm going to take 4 and 5 and figure out what do I have to do. They made it easy for us in number 3 because once we get 4 and 5, I see a 3z, negative 3z. I'm simply going to take equation 4, which is 2x plus 3z equals 13. And I am just going to add it to equation 5 because that's 3x minus 3z equals negative 3. So I'm just adding them. That's all I'm doing. I combine those. And I end up with 5x. My z's go away. 13 minus 3 is 10. I simply divide and find out, hey, cool, x equals 2. Now I take that x equals 2 and I plug it into either one of these. It doesn't matter which one. I'll take equation 4. I'll still label it. 2x, well, I figured out x is 2, plus 3z equals 13. So now I have 4 plus 3z equals 13. I'm going to subtract 4. 3z equals 9. Z equals 3. Now I go back up to the top and choose any of these. Obviously, this is the easiest. X, Y, Z. I'm going to choose equation 1. And I solved X was 2. And equation 1 said X plus Y plus Z. Well, my Y, I never solved it. I eliminated it. But I did solve Z. X plus Y, didn't know it. Z, I solved Z. 3. And that all equals 6. Equals 6. So what I have is Y plus 5 equals 6. Minus 5, Y equals 1. And this is an ordered triple. My X is 2. My Y is 1. My Z is 3. So number 3, that's how we write our answer. Takes a lot of time because we have to make 2 new equations. They give us 3, but we need to make 2 new. We have to make a 4 and a 5 that each eliminate the same variable. Okay, now 19 gives us something a little different. It looks super easy until we start doing it. Like, oh crap, wait a minute, what the heck? Oh, well, they're giving us systems of 3 variables, but they're only giving us equations that have 2 variables. So it doesn't really change anything. We just have to eliminate one of the variables in 2 different ways. Well, really only just one of the variables. You'll see. I'm going to take Y plus Z equals 3. I'm going to take number 2. Y plus Z equals 3. I'm simply going to add it to 4x minus Z equal, well, I should do that, equals 0. Because when I do that, my Z's go away and I have 4x plus Y equals 3. Now, it doesn't really matter what route we go here. You can see that there's an X and a Y here. There's a Y and a Z here. There's an X and a Z there. There's no way to really quickly get rid of one and automatically make it work. None of them are the same. I just chose one. Those go away. Now I have an X, a Y, 3. Up here I have X, Y, 2. So obviously what happens here is I'll say that's 1, that's 2, that's 3. I made a 4th. However, I don't have to make a 5th. I have to take, I'm just going to do an extra step. I have to take one of these that matches up. I have an X and a Y. I have to find which one has an X and a Y. So I made my own. Didn't matter which one. I could have done these 2 and got rid of my Y. I could have done these 2 and got rid of my X. I saw plus Z minus Z and just went with it. So I took 2 plus 3. Equation 2, equation 3, added them. And I ended up with 4x plus y equals 3. That's my 4th equation. Because I'm dealing with 2 variables in each equation, I don't need a 5th. I just need to pick which one matches up. And in this case, they make it pretty easy. I only have to negate. So I'm just going to subtract. Negate, multiply through by -1, or just think, well, I'm just going to subtract. 4x minus 2x is 2x. Y minus y, they go away. 3 minus 2 equals 1. So x is 1/2 for number 19. And yeah, it's a fraction, but we'll see what happens. What happens is you just choose a place to plug it in. Again, I'm going to choose 1 because 2 and 2 will go away. I'm always looking for something that'll make the denominator go away. 2x, x is 1/2. 2 times 1/2 plus y equals 2. My 2's go away. 1 plus y equals 2. I simply subtract my 1. Well, now my y is 1. So now I could plug it back in there and solve. I'm just going to choose number 2. I mean, choose the easiest one. Choose whatever you see that seems easiest. I need z. I need to solve for z. Well, here's y plus z is 3. That's simple. Go with the simplest one whenever you can. Save yourself some work. y is 1. Y plus z is 3. Well, I found out y is 1. So 1 plus z is 3. Z equals 3 minus 1, which is 2. My ordered triple is 1/2, 1, and 2. Takes work. Don't get frustrated. Keep at it. I think these are fun when you start getting them right. Once you start figuring out what's going on, you can choose any of them. That's the hard part with it. There's no right answer on where to start. I chose z. I chose plus z minus z. Let's make z go away. Anybody could have chosen 2 and 1 and said, hey, let's get rid of y's. Somebody else could have chose 1 and 3 and said, I'm going to get rid of x's. So doesn't matter where you start, these will work out the same no matter what. So just kind of analyze it a little, choose a starting point you're comfortable with. Hopefully you enjoyed that. I didn't blabber on too long.